Hi, this is lesson 32 in the use of JASP for understanding statistics. And today we're looking at the two-factor ANOVA. Specifically, we're doing a 2 by 3 factorial design. And this example is taken from a textbook by Andy Fields, who constructed some fun examples, and which is also in the data library for JASP. So what he does in this study is he looks to see whether or not people become blind to the attractiveness of another person as they get drunk. So the idea is that if you had someone who was previously rated as unattractive, they would be, the drunker the person is, the more attractive they would see the individual. And so that's the example. And the way that I would teach students to conceptualize this would be in this 2 by 3 factorial framework, where the cell means are in the boxes. This is for judging an unattractive person. Placebo, no alcohol consumed, a medium amount of alcohol consumed for level number 1. Level number 2 is a high dose of alcohol consumed, and we do this for both the unattractive individuals and the attractive individuals. And we get our cell means and we get our marginal means. The marginal means are, of course, the averages going across this way, and then over here, the averages going across here, then over here, averages this way for our columns, averages for level 1 for factor B, average for level 2 of factor B. Okay, that's the design. Let's see what we find. Go to JASP. Open it up from the data library. Go to ANOVA. Go down to beer goggles. Beer goggles is what it's called. Let's get rid of the instructions and just start with the data. I want to make clear what the labels are. Right here, he just enters in the numbers, and they're 1s and 0s. I would typically do 1s and 2s. For alcohol, I would typically do 1 and 2 and 3, but we have 0, 1, and 2. So what I want to do is double left click on face type, and for 0, we're going to put unattractive next to the 0, click on the 1, and put attractive. Click someplace else other than that cell, then close the window, apply the changes, and now we have the labels along with the numbers. The numbers are shown grayed out. Go and let's do the same thing for alcohol. Double left click on alcohol for 0. We're going to put placebo. For 1, we're going to put low dose. For 2, we're going to put high dose. We're going to retain the numbers that were originally assigned. Click someplace else so that the changes take. Close the variable window by clicking on the red X in the right upper corner. Hit apply, and our data set is ready to go. We have attractiveness as our continuous variable. It is denoted as a scaled variable, which fits with continuous. Click on ANOVA, classical ANOVA. We have 2 independent variables. Those are face type, which is going to be factor A, alcohol, which is going to be factor B. Plug both of those in and plug in attractiveness. It runs the analysis. I want you to notice that if you look under model, it already assumed that since you put 2 factors in, you must want the interaction. If you didn't want the interaction, You could click on it and take it back out, and then you have to redo things in order to get it back in, take everything out, put the two components in, and it plugs in the interaction. So it automatically assumes that you want the interaction and designates that by a multiplication sign. Okay, so we have the main effect for factor A, and our F is 15 with 1 and 42 degrees of freedom. It is less than, the p-value is less than 0.05, so it is considered significant. A significant effect for face type. People see, this is basically a manipulation check. We don't actually know what that means yet. If we click on descriptive statistics, you'll see that the means for attractive individuals tends to be higher than the means for unattractive, which is the interpretation. We also have a significant main effect for alcohol, and we're going to need to interpret that. We know that it's significant because with 2 and 42 degrees of freedom, we have an F of 6. With 2 and 42 degrees of freedom, an F critical is generally going to be in the range of around 3. So that's your first clue that we're well above a 3. But more specifically and more importantly, our p-value is 0.005, which is less than 0.05. So the probability of a type 1 error is exceedingly small. And so it's a significant main effect for alcohol. Finally, we have with 2 and 42 degrees of freedom, 2 and 42 degrees of freedom, an F value for our interaction effect of 8.507. Is less than 0.05 with the p-value, and hence it is considered a significant interaction effect. The residuals is your between group variance that's used for the F-test. Okay. So we want to interpret the results. We want to do two things to interpret the results. Importantly, since we have an interaction effect, we want our descriptive plots. So go to your descriptive plots. There's two ways of analyzing this. You could put in face type for the horizontal axis and then alcohol for the separate lines. There's nothing wrong with doing it this way, but it is more complicated. Generally, when I have a 3x2, I'll take the factor that has 3 levels and put it on the x-axis. So let's redo it. Take this out, take this out, take alcohol, put it on the horizontal axis because it has 3 levels. Face type, since it only has 2 levels, which will give us 2 separate lines, put it under separate lines. Take your graph, stretch out the graph, and when you stretch out the graph, it tends to show up nice and pretty, and you can see what's going on. And what we see is consistent with the expectations for this wild example. For attractive people, it doesn't look like the alcohol dose, how much beer they drank, none, a little, a lot, mattered in terms of how attractive they put the person. Either way, on average, they considered those pictures at around attractiveness level of around 6.5. But for the unattractive individual, they started off with a rating of about 3.5, then for low dose went up to almost 5, then went up to around 6.5 for once they're drinking a high dose of beer. So it seems to be catching up. With a high dose of alcohol, they tend to be coming in around the same level of attractiveness as if it was an attractive person. Okay, that's what it looks like. And you see the non-parallel line structure, which makes it looks like an interaction, but we always depend not on what we see here, but upon our F values. And the F values do indicate a significant non-parallel structure because we do have a significant interaction. But how do we test these things more specifically. I want to look at, first of all, what is the main effect interpretation for face type? In order to do that, we want to look at our marginal means. So let's go to marginal means for face type. And here's the marginal means for face type. And basically, this significant effect says that we can interpret these differences. Now, that difference of 5 and 6.33, you'll remember from my Excel sheet, here's the 5 and 6.33. So I have my F with 1 and 42 degrees of freedom is equal to 15.58, and that was significant. P less than 0.05, or you could say P less than 0.001, but I'm going to go with the traditional P less than 0.05. So that is a significant main effect for face type. And the interpretation is right here between these two means, which I'll put in yellow. Okay, that's what we got from this over here. This first line allows us to interpret this difference. Now let's put in the main effect for alcohol. I have three means here, 4.938, 5.688, and 6.375. So where was that in my original drawing? Go back up, get my Excel spreadsheet, and here are those numbers, the 4.938, 5.688, and 3.375. So I'm going to give this a different color, orange, and I'm going to say F with 2 and 42 degrees of freedom is equal to 8.27. P is less than 0.05, or you could say P is equal to 0.005. So that is my significant main effect for alcohol dose. Okay, now I have three means. If I have three means, how do I tell where the significant differences are? Well, you can go to post-hoc test. And for post-hoc test, let's go to alcohol and put in Tukey's. And I'm going to say to flag the significant comparisons, and I'm going to ask it to do a letter-based grouping table, which is really, really useful for being able to tell where the significant effects are. So this shows the comparisons of each group with the others, and shows that there's only one significant difference, and that's between the placebo and the high dose. So between this group, placebo and high dose, that's where the significant effects are. I like the letter-based groupings because you can basically just go ahead and note A and B for low dose, and B for high dose. Remember, placebo, low dose, high dose, placebo, low dose, high dose. And it's showing A, B, and B. Now, the trick is with these, if the subscripts are not different, then there's not a significant difference. So since both this mean has an A and this mean has an A, then they're not significantly different from one another. But the 4.93 does not share a subscript in common with the 6.375. So the placebo is different than a high dose. But this one is not different than the high dose, and it's not different than the low dose because it shares an A with the low dose and it shares a B with the high dose. So it's a nice way of getting down where your significant differences are so that you can lay that out. Finally, we have the interaction pattern, but where exactly are the significant differences? That's getting pretty specific, and I don't get into that in my stat class for undergraduates, but we can first see the marginal means by placing it over the marginal means, and then here it is, but we had the marginal means from the descriptives in the first place. This is giving you a little bit extra information for being able to tell where the significant differences are. But you can also go to post-hoc test, go back up to post-hoc test, take face time times alcohol and plug that in. And here it tests every comparison, which is a lot, and it's a mess, right? I mean, that's hard to digest. So again, what I like to do is to use that letter-based grouping table, because now I can basically just focus on that. Here's my design. For the interaction, we're focused on these means. And I'll do those in green. And the letter-based grouping starts with unattractive placebo is an A. Attractive placebo is a B, C. The unattractive low dose is an A, B. The attractive low dose is a BC. And the unattractive high dose is a C, and the unattractive high dose is ABC. Okay, now while looking at these letters, let's look back at the figure. All of these for attractiveness, whether it's low placebo, low dose, or high dose, all have BCs. None of these are significantly different than each other. Great, so we know that. And then we have for the placebo, it's an A, so it's significantly different than all of these four means up here. It's not significantly different than this one, the 4.875. Both of these, the placebo and the low dose, are significantly different than this. So that's great. So that tells the story that once they've gotten really drunk with a high dose of beer, they don't see any difference between the attractive and the unattractive individuals, and in comparison to if they were viewing an unattractive person with a low dose of the beer or the placebo over there. And you have your storyline. Okay, I'd like to recap by making one additional point. So you do your two-factor analysis of variance. You have two significant main effects, and you also have a significant interaction. The interaction takes precedence over the main effects in terms of interpretational value. That is, the interaction modifies the main effect, so you want to always pay attention to that. You still can go ahead and interpret your main effect. So you interpret your main effect for face type here. You interpret your effect for alcohol dose, and then you focus on the interaction. To focus on the interaction, what you want to do is to talk about the simple main effects. So simple main effects are what is the effect of alcohol at the dose or at the level of judging unattractive individuals. So I'm going to go ahead and mark that in light blue. And then you would also have a simple main effect for alcohol at the level of the attractive individual. And so I'm going to mark that in darker blue. What you're essentially doing at this point is you're taking this main effect that you've already explored for alcohol dosage, and you're now admitting that there's a modification of that effect that is due to face type. And so you're going to redo the analysis that you did here by looking at what is the simple main effect for unattractive individuals, the simple main effect for attractive individuals. So go over down here on JASP to simple main effects, and we want to look at the simple main effect for alcohol as a function being moderated or changed by face type. And look down at the very bottom, and it redoes 2 F-test that can be reported with degrees of freedom of 2 and 42 degrees of freedom as you had it up here. So with 2 and 42 degrees of freedom, you have a significant effect for the unattractive, no significant effect for the attractive. In other words, you're now reporting that you have a significant difference in the means between here, here, and here, which we've already explored in more specifically doing the post-hoc test, and no significant effect here, which we already deduced via the post-hoc test. So there is some redundancy with the post-hoc test, but reporting it in terms of the simple main effects is the better way to actually systematically go through your analysis reporting. Thanks so much for your attention. We'll talk to you next time.